Hello everyone, in this video I'm going to discuss the example for equation and absolute value inequalities. First, refers to the question, shows that we have the 4n divided by, we have 8 to the power of 2 over 3n. Multiply with the 16, we have the power n over 2 equals to 2 to the power of 2n. So question asks us to show. So if you want to show, we have to refer to the left hand side only. So ignore the right hand side. So kindly make use of the situation. Question asks us to show that with the base 2. So rewrite the situation. So we have 2 to the power of 2 bracket n. Divide by, we have 2 to the power of 3 bracket 2 over 3 n. Multiply 2 to the power of 4 bracket, we have n over 2. So kindly simplify. So 2 to the power of 2n divide by 2 to the power of 2n multiply 2 to the power of 2n. So if it refers to the situation, for this part, actually we have 2 to the power of 2n over 2 to the power of 2n, and then multiply 2 to the power of 2n. So if we simplify, and we will have 2 to the power of 2n. So from here, we have 4n divided by 8 to the power of 2n over 3. Multiply with the 16n over 2, and we will have 2 to the power of 2n. So we already shown the situation. Next, hence, solve the situation plus with the 4 minus with the 5 multiply with the 2 to the power of n. So notice that we have this part which is the same. So we can substitute the situation. 2 to the power of 2n plus with the 4 minus with the 5 multiply with 2 to the power of n, which is equals to 0. So rewrite the situation. 2 to the power of n bracket, we have the square, plus with 4 minus with 5 bracket 2 to the power of 2n equals to 0. So let y is equals to 2 to the power of n. So here we can say y squared minus 5y plus with the 4 equals to 0. So y minus 4, y minus 1 equals to 0. So 2 to the power of n is equals to 4. 2 to the power of n is equals to 1. So from here, 2 to the power of n equals to 2 to the power of 2. 2 to the power of n is equals to 2 to the power of 0. So if you compare the base, so n is equals to 2, n is equals to 0. So making use of the situation, then check the validity, valid for both situations. Next, we have the situation for absolute value inequalities. Find the solution set of the inequalities. So here we have to rearrange the situation. So the modulus of x greater than, we have the x squared minus with the 6. By referring to the definition, we have the modulus greater than x squared minus 6. So we have x is greater than x squared minus 6. Or we have the x less than, we have the negative bracket x squared minus 6. So here we have the definition. So first of all, kindly rearrange the situation. So here we have the x squared minus the x minus the 6, and we have less than 0. Kindly factorize the situation. So x minus with the 3, x plus with the 2. So from here, notice that it is the simplest form. So pick the sign where we have the negative. So split or assume always positive. So x greater than 3, x greater than negative 2. Kindly illustrate the situation in a real number line. So we have the negative 2 and also the 3. So empty circle towards the right, empty circle towards the right. So here we will have negative, negative, negative. So positive, negative, and positive. By referring to the sign, we want the negative sign. So negative 2 until 3, where the negative 2 and 3 is not included for the left hand side. Next, move on with x less than, we have the negative x squared plus with the 6. Rearrange. So we have the x squared plus with the x minus with the 6. Then we have less than 0. So here we have x plus with the 3, x minus 2, less than 0. Again, simplest form. So we want the negative sign. So x greater than negative 3, x greater than 2. Illustrate the situation in a real number line. So we have negative 3 and 2. So empty circle, and here we have the negative. So positive, negative, and positive. Again, we select the negative by referring to the sign at the top there. So the answer would be negative 3 until 2, where the negative 3 and 2 is not included. Then based on the definition, we have all. So kindly illustrate the situation in a real number line again. So the number involved would be negative 3, negative 2, and then 2, and then 3. So the answer number 1 for the left hand side, negative 2 until the 3. Where the negative 2 and 3 is not included, then second answer, we have the negative 3 until the 2. Where the negative 3 and 2 is not included. Continue. Based on the definition in here, all. So here will be our situation. Shaded the region. So the answer would be, start from negative 3 until 3. Where the negative 3 and 3 is not included for the situation all. So express the answer in the interval form, then in the set solution or set notation. So x such that we have x greater than negative 3 less than 3. So here we have the set solution.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.